More 4.3 properties of logarithmic functions preparation. Alright, so we're going to use the power rule part C, which takes a fraction within parentheses to a power, which effectively takes the numerator to that power and the denominator to that power. Alright, so let's get started. And we have 2/3 within parentheses to the 5th power. So effectively we are going to take the 2 and the 3 to that power. So we're going to say 2 to the 5th power and 3 to the 5th power. Now 2 to the 5th power gives you a 32, and 3 to the 5th power gives you 243. And that doesn't simplify. Moving on to the next one, we end up again, we bring the numerator and the denominator to that power. So we end up with 1 to the 4th power and 5 to the 4th power, which gives me 1 over 5 to the 4th power, which is 625. Over here, again, we bring the numerator and the denominator to the 4th power, which gives me m to the 4th power over n to the 4th power. We have a list of the rules for exponents right here on page 138, so that's a good reference if you need a reference for some of the rules of exponents. Now we're going to combine a few of these rules together. So, let's say we have 2/3 within parentheses to the 2nd power. That's going to give the numerator 2 to the 2nd power over the denominator 3 to the 2nd power. And then we're multiplying it by 2/3, but since we're multiplying it by a fraction, we're going to put it over a 1 because it's over a understood 1. And we're going to multiply it through. So we end up with the numerator 2 to the 2nd power multiplied by 2 to the 3rd power, so we add their exponents together, and 1 times 3 to the 2nd power is 3 to the 2nd power. So 2 plus 3 is 5, so we end up with 2 to the 5th power over 3 to the 2nd power. 2 to the 5th power is 32, and 3 to the 2nd power is 9. Next we have 5x to the 3rd power times 5x to the 4th power, and both 5x's are within parentheses. So in this case, the bases match. So we are simply going to add their exponents, 3 plus 4. So 5x to the 3 plus 4 power, which gives you a 7 power. So then it looks almost like distribution. We're just simply going to stick that 7 exponent on both your 5 and your x. Okay, so the next set, we have 2x squared y to the 3rd to the 4th power, 3xy to the 2nd power, the whole thing is to the 3rd power. Now, since in this case the bases don't match, we're going to do the equivalent of distribute this, kind of like that. We're going to bring all of these individual factors to the power. So we're going to end up 2 to the 3rd power times x to the 2nd power to the 4th power. So we multiply the 2 and the 4 together. And then we have y to the 3rd power to the 4th power, so we multiply the 3 and the 4. Then over here we're going to have 3 to the 3rd power. We're going to have x. Now since x doesn't have an exponent, or has a understood 1 exponent, 1 times 3 is 3. Then we have y to the 2nd to the 3rd, so we simply multiply those together. So 2 to the 3rd power is 8. X to the 2nd times 4, so that's going to be x to the 8th power, and y to the 3 times 4, which is 12. Then we have 3 to the 3rd power, which gives me a 27. Then we have x to the 3rd power, and we have y to the 6th power. All right. So this would give me 8 times 27, which is 432. And then we have x to the 8th times x to the 3rd times y to the 12th times y to the 6th. So in both of these cases, so we have x to the 8th times x to the 3rd, so we add the 8 and the 3 together and get 11. We have y to the 12 times y to the 6th, so we say 12 plus 6 gives me an 18. So final simplification is 432 x to the 11th, y to the 18th. Okay, so the next one we have negative x to the 3rd y squared, and then we have negative x to the 5th y to the 4th cubed. Now the bases are not the same, so we have to simplify these separately. So because I'm squaring this negative x to the 3rd y to the 2nd, I'm going to make it a positive, right? So then I'm going to say positive 3 times 2, because you're bringing a 3rd power to a 2nd power, so you multiply, and it's going to be y to the 2nd. Next, I have a negative to a 3rd power, so I keep the negative, and then I'm going to say x to the 5th power to the 3rd power, which means 5 times 3. And I'm going to have y to the 4th power times 3. Okay, so we have x to the 6th, y to the 2nd, times a negative, x to the 5 times 3, which is 15, y to the 4 times 3, which is 12. Negative times a positive is a negative. So we end up with a negative. I'll even put these next to each other, right? X to the 6th times x to the 15th, y to the 2nd times y to the 12th. So 6 plus 15 is a 21. Y to the 2nd times y to the 12th. You're going to say 2 plus 12 is 14. And that's it. All right, so let's scroll down a little bit. Now, anything to the 0th power is 1. All right, so 60 to the 0th power is 1. And we have negative 60 to the 0th power. Now, since this is in parentheses, you're bringing the entire negative 60 to the 0th power, so the whole thing turns into a 1. Now, in this case, this is the equivalent of negative 60 to 0. Since the negative 60 is not within parentheses, that's the equivalent of negative 1 times 60 to the 0th power. In which case, the negative 1 stays. 60 to the 0th power turns into a 1. 1 times negative 1 is negative 1. So effectively, the negative is just carried forward, right? And we bring over the 1. So we have y to the 0th power, which is still 1, right? Over here, we have 6 times y to the 0th power. So the y to the 0th power turns into a 1, and then you end up with 6 times 1, which is just 6. Over here, we have 6y within parentheses to the 0th power, so it brings the whole thing to a 1. Here we have 8 to the 0th power plus 11 to the 0th power. 8 to the 0th power is 1. 11 to the 0th power is 1. Oops. And then 1 plus 1 is 2, right? Here we're going to say negative 8 to the 0th power is negative 1, minus 11 to the 0th power is 1. Negative 1 minus 1 is going to be a negative 2. And that's it.